So here you can kind of see it the way it works. We've got our foam, and then I've covered the foam in a cementitious glass reinforced concrete mix. And then that's finished in a type of, well, a finish coat of various types. The problem with cementitious finish coats are the lack of flexibility and cobwebbing, among other things. But really it's the cobwebbing, so I'll show you here the deficiency. It looks good, and then the water hits it and you can see the micro cracking. You see that? All concrete does that. And it's probably one of my principal frustrations using this material. All concrete cracks, it shrinks. There's a couple of reasons for that, and you can't stop it. Nice material, workability's poor, and it's really quite brittle, but very hard. This, on the left, is lime plaster. And this is basically what the world was made of from 10,000 BC until about the mid-1800s. Completely different product. It doesn't shrink when it cures, and it takes pigment perfectly. It's flexible. It doesn't have the same compressive strength that concrete has. But for this application, or for various applications, it's unreal. It lasts for centuries, right? Concrete lasts for decades. So humanity kind of made a trade-off when we moved away from this type of material into Portland cement. But that's a whole other story. So you can see my deficiency here. So I had to solve this problem in order to get something that I was happy with. So moving on, the lime is this material. And it is just, I don't know if you can see in the video, but it's just an extremely luxurious finish. That's a range hood that I've built, and it has a styrofoam core, which you can see in there. And it's been covered, well, there's a couple of different attempts, but that's been covered in lime plaster. When lime plaster hardens, it essentially is chemically indistinguishable from marble. So it's basically pure calcium carbonate when it's finished. So here you can see an interesting shape that I'm experimenting with that shows the flexibility of the method. This is a base for a coffee table I'm going to make. So this started as a styrofoam core, and I've now applied the glass reinforced concrete to it. It's kind of neat. Definitely going to hold a lot of weight there. Compression, tension. Here, I've got tons of compressive strength because of the inherent nature of the concrete material. And along here, there's embedded scrim, among other things, to create an extremely strong shape. So it's kind of a test piece. It's interesting. That's going to be covered in the lime, right? And you would think, well, it's got to be pretty heavy, but you just saw that I can move it, right? Moving on, got a bunch of pieces here. This is a tabletop, 6-foot diameter, 3 inches thick. It's got a 2-inch foam core, 1/2 inch of glass reinforced concrete on the top, 1/2 inch on the bottom, 1 inch on the sides. I've covered it with the base coat of the lime yesterday. This is the inherent color of the material, which is a lot nicer than Portland cement. Cement has that gray, kind of dead color. This is going to be finished in more lime. And I'm going to create something there called Tadillac, which is basically a technique whereby you use different grades of marble to create a really, really smooth finish. This is a test pedestal here, and you can see the pigment quality. You can't get this with Portland cement. Portland cement destroys pigment, and this just loves pigment. The Sistine Chapel and all of that kind of stuff that was done during the Renaissance was basically pigment applied to fresh lime plaster. And then when it cured into essentially limestone. Goes through a process called carbonation, where it reacts with the carbon dioxide in the air and creates basically calcium carbonate. It's fascinating. That's why those frescoes are still here hundreds and hundreds of years later. So it doesn't degrade pigment, it doesn't shrink. It's extremely flexible. I mean, not flexible like rubber, but, you know, relative to Portland cement, for example. This is a base for the tabletop that's over there. And once again, this is a styrofoam core. I did a little wet clay mock-up of the thing. I carved it with a hot knife. I applied 2 coats of glass reinforced material to that. And I wanted to make a shape that was organic. Something that couldn't come out of a mold, if you know what I mean. But what's fascinating about this is you can polish this now and basically have a material, I don't know if you can see it here. You can sand this stuff. Hey, buddy. And you can imagine what it must have been like for some of the guys that were carving marble. To get to this point would take days, weeks of chipping and rough cutting to get to the point where you actually create these organic shapes, right? So, really fascinating stuff, right? You couldn't make that shape any other way, and there are no cobwebs, there are no cracks in any of this stuff. Even though the underlying material, the glass reinforced concrete, is susceptible to micro cracking, but it doesn't shadow through this stuff. And that's principally the difference, right? It's unfortunate that we've moved away from it. These are 2 pedestals that I've just started making. And I mean, this stuff goes fast for me. I'm used to using trowels, of course, but these are going to hold up a rustic wood shelf. And they're foam core again. I only used about a 1/4 inch of glass reinforced concrete on these. 24 hours later, I put the first coat of the lime plaster on here, and then I'll do a finish coat on those. So that's kind of what's going on here. I mean, it's a little bit of a sculpture garden, but I'm pretty excited about it. And most of this stuff came together really quickly for me. You know, it's a heck of a lot easier to carve that stuff than it is to, you know, well, carve just about anything else. So most of these pieces are going to find a home shortly. That one's going to our kitchen. That's going in the living room. That's going in the garden. That's going in my daughter's basement, sitting on top of that. Those are going in the basement. And away we go. So I thought I'd get a little documentation here before all this stuff moves out. That's the sprayer. That's a peristaltic pump that pumps glass reinforced concrete, which is really, really tough stuff to pump because of the fiber in it. So, you know, spraying or hand troweling is perfectly fine for this stuff. I've got the mixes all dialed in. This has taken years to figure out, but I feel like I'm just had a nice little breakthrough here, so I'm actually producing pieces. I'm doing this all myself. It's not really too bad. Old guys can do stuff like this. Right, Tinky? Okay. That's the story on that, at least for now.